Hello, welcome to this lecture. In this video, I'm going to continue explaining about probability. In the first video, we already discussed about revision of set theory, which will help us to understand about probability. So I'm going to describe and list sample space and events. And of course, we are going to define what probability is. What do you understand by the word probability? So probability is the chance or the likelihood or the uncertainty of having the result of an experiment. And what is experiment? Experiment is the process of doing something. But if we are doing that process many times, we call it probability experiment. As an example, can be a simulation. When you run a simulation many times, you may have error. So what is the probability of the occurrence of the error? That is probability experiment. The example given in the slide is if we have a fair die and roll it. A fair die is an object which is six-sided, which has equal chance of occurrence in each side. If we give number 1 and also 2 or 3 or 4 or 5 or 6, and this result is called outcome, then what is the probability of having 4 or the probability of having 1 or the probability of having 2 and so on? If we put all results in a set in such a way that 1, 2, 3, 4, 5, 6, and then it is called sample space. Event is a subset of a sample space. Let's consider the same example, which is tossing a die one time. One subset can be event of odd numbers, or it can be event of even numbers, or it can be event of 8, like the example which is given. It says C be the event of number 8. For example, is 8 here? No, because number 8 is not in the sample space. Then C is empty set. But A is 1, 3, 5. B is 2, 4, and 6. What is equally likely events? These are events that has equal chance to occur. Elementary event, as the name indicates, elementary is just single value. So it's an event having only a single element. For example, a set with only 3, or a set with only 5, or a set with only 1, we call it elementary event. Independent and dependent events. If the occurrence of one event doesn't affect the occurrence of the other event, we call it independent events. But if the occurrence of one event affects the occurrence of the other event, and we call that dependent events. To describe these events, I'm going to use an experiment as an example. I have 7 balls inside. 2 are white, 2 blue, and then 3 green balls. Suppose I select 2 balls randomly, and then I put them again. Is the occurrence of taking 2 balls from the box, will it affect the occurrence of the next event? No, because I already put them inside again. So the first 2 balls, they have also the chance to be selected in the next. Such events, we call them independent events. So the first event doesn't affect the occurrence of the next event. But I'm going to select 2 balls, again the same, put them somewhere. Now I'm going to select 2 or 3 balls. Is the occurrence of the first have an impact on the selection of the second? Oh, yes. So such events, we call them dependent events. Complement of events, mutually exclusive events, union, intersection, we already revised it in the first revision video. So if you want to know about these terms, please refer my first revision video about set theory. Now we are going to list sample space. We said sample space is all possible outcomes of the result of an experiment. And we put it in a set. The first one is toss a die 1 time. We already saw the sample space for this one. It is this one. The next example is toss a coin 2 times. I may have 2 coins or 1 coin, but tossing twice. When I toss 2 times, I may have, the first activity is head, tail. And the second activity is also head, tail. So what will be the all possible results in a set, which is a total sample space, will be HH or HT or TH or TT. You can also use like this. Do this, like this, like this, like this. And we call this one a tree diagram that I will show you later also. The third example is when we have an experiment which we cannot list the number of elements. For example, the example in here, it says a light bulb is manufactured. It is tested for its life length by time. This is a continuous variable. A continuous variable is a variable when there is no gap between consecutive observations. For example, in the case of the first sample space, which is 1, 2, 3, 4, 5, 6, I cannot say 0.2 or 1.2 because there is gap between consecutive observations. But when I have an experiment that is measured in terms of continuous, for example, time, then I have to represent it in a continuous way. That's why I use T, say that T is greater than or equals to 0. We can also use a tree diagram to list the elements of the sample space. What is the advantage of listing the sample space? Because we are going to use the number of the sample space to calculate a probability. That's why. Example, a student goes to the nearest snack to have breakfast. He can take tea or coffee or milk with bread, cake, and a sandwich. How many possibilities does he have? Let's say coffee, tea, and then milk. When you take coffee, you may take it with a bread, or with a cake, or with a sandwich. Or you may take the tea with bread, with a cake, with a sandwich. Or the milk is also similar, with bread, with cake, and with sandwich. How many possibilities? 9 possibilities. So now we list. Let's consider another example. Each message in a digital communication system is classified as to whether it is received within the time specified by the system design or not. If 3 messages are classified, let's use the tree diagram to list the sample space. If it's received, I am going to say received are, let's say, and then maybe error E, not received. Or I may also use yes, no. It's up to you which notation to use. Let's use yes, no. I have how many messages? A message 3. Message 1, I'm going to say either yes or no. And then message 2 is also here, yes, no. Here, yes, no. Message 3 is also yes, no, yes, no, yes, no, and then yes, no. So the possible results will be in a set S, can be yes, 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 no, or yes, no, yes, or yes, no, no, or no, yes, yes, no, yes, no, 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 yes. So how many possibilities? 8 possibilities. You can check it here. So this is how you can list the sample space. Thank you very much. And please share and comment. If you have any question, you are welcome. And see you in the next video.